All right, everyone, welcome to a new session. Today we have Sumit. Round of applause for Sumit. Sumit, Sumit is my batchmate from IIT Roorkee. He's been working at Zoopy for 5 years. Zoopy hyperscaled in the last 5 years. It's one of the biggest Ludo companies in India. They have a bunch of other products. Biggest product is Ludo, I think. Is that right? So he's seen all the journey from the starting. Product भी शुरू में start किया, फिर DevOps देखा है, फिर DBA देखा है, सब देखा है. They host their database also in house. ये मुझे आज पता चला. तो ये सारी जो insights हैं, वो दी जा रही हैं आज जो 5 साल में Sumit has gained. With that, Sumit, over to you.
So hi everyone. So I'm Sumit. I'm 100x's batchmate. He was also just next to my room in first year. तो काफ़ी memories है college की. But here we are mostly going to discuss technology, right? So I've been connected with technology since college. मतलब second year से mainly coding चालू हुई थी. But I think every one of you is here to learn something, try to get a job in tech, right? And basically become good at tech in any way possible, right? So whatever you are learning today might not be the things that you might do in future, right? अभी जो आप कर रहे हो क्या पता आपका टेक स्टैक बदल जाए, आपकी जो भी स्किल्स है अभी डेवलप कर रहे हो आप 5 साल बाद कुछ और कर रहे होगे, राइट? तो जो हम कॉलेज में करते हैं या फिर स्टार्टिंग में करते हैं, we might be doing very different things from what we started from, right? I started with Python, Ruby on Rails, and I don't know those things right now. ठीक है, तो Ruby on Rails की आई थिंक रिसेंटली पिछले 2-3 साल में मेरे को इंटरव्यूज भी आते हैं कि आप Ruby on Rails में काम करना चाहोगे. मैं बोला यार मेरे को 10 साल हो गए Ruby on Rails हुए हुए, अब मेरे को कोई आइडिया नहीं है उसका. एंड अगर आप उसमें स्टार्ट कर रहे हो तो मैं रिकमेंड करूँगा स्टार्ट भी मत करो. राइट? तो टेक्नोलॉजी बहुत तेज बदलती है, राइट? बट इन दी एंड आपके कंसेप्ट्स मैटर कर जाते हैं. जो आप बेसिक्स कंप्यूटर साइंस के जो कंसेप्ट्स हैं वो मैटर कर जाते हैं. एंड जितनी भी कंपनीज में आप काम करोगे इन दी एंड कोई ना कोई बेसिक कंप्यूटर साइंस का कंसेप्ट है जो आप इस्तेमाल कर रहे होगे. कितनी भी बड़ी चीज़ बना लो, कितने भी बड़े सिस्टम्स बना लो, इन दी एंड वो छोटे छोटे कंसेप्ट्स मिलके ही आप कुछ बड़ा बनाते हो. ठीक है? तो आई थिंक रेडिस पे लोगों को आइडिया है कि क्या है रेडिस. एंड किसी ने एक्चुअली कुछ प्रोडक्ट बनाया है रेडिस यूज करके? कितना हैवीली आपने यूज किया रेडिस को? मतलब डूइंग ए वेरी बेसिक यूज केस या फिर आपने पूरा ऐप ही उससे बना दिया? बेसिक यूज केस, पब सब एंड क्यूज. आई थिंक काफी अच्छा है ये तो कि लोगों को पता है ऑलरेडी. So if you might have made some toy projects, now I will show you like real apps में भी ऐसा हो सकता है, right? If you are going to make a toy project which is competitor to a big company as well, अगर आप वैसा भी एकदम क्लोन भी बना रहे हो, तो there are very basic concepts of Redis that you might be using in real systems as well. And we at Zoopy also use Redis very heavily, and I am acting as a database administrator of Redis as well. So I've seen Redis breaking in multiple areas, multiple production systems have went down because of Redis, and काफी scale पे हमने systems को फटते देखा है. And तो Redis is a very good product. काफी पहले आया था, I think 2009 या 2011 में आया था, 2009 में आया था. एंड सबसे पहले आई थिंक इंस्टाग्राम ने उसे यूज़ करना शुरू किया था. एंड इट्स ए वेरी गुड प्रोडक्ट, वेरी सिंपल प्रोडक्ट, वेरी सिंपल मेथडोलॉजी एज वेल. एल्गोरिदम्स भी काफ़ी सिंपल है, डेटा स्ट्रक्चर्स भी काफ़ी सिंपल है, एंड इट इज़ वेरी स्केलेबल सिस्टम, राइट? आप हॉरिजॉन्टली भी स्केल कर सकते हो इफ़ यू हैव ए क्लस्टर, एंड इफ़ यू हैव ए स्टैंड अलोन आप वर्टिकली भी काफ़ी अच्छे स्केल तक जा सकते हो, राइट? एंड डज एनीबडी नो लाइक रेडिस है क्या? लाइक व्हाई इज इट कॉल्ड ए डेटाबेस? In-memory database, right? So we'll start with things, right? Why in-memory database? So database का फंडा सबको पता है, right? कि database होता क्या है, right? कोई explain करना चाहेगा? Storing a data, right? How does it store data? कोई idea? right. So data कहीं ना कहीं जाके डिस्क पे स्टोर होता है, राइट? इन मेमोरी का मीनिंग ये है कि यू डोंट हैव टू टच द डिस्क. ठीक है? व्हेन यू टच द डिस्क आपकी लेटेंसी बहुत ज़्यादा बढ़ जाती है, राइट? एंड द लेटेंसी इज द वन थिंग दैट मैटर्स एट स्केल. अगर आप SLA की बात करते हो कि एक अच्छा SLA क्या होता है, सर्विस लेवल एग्रीमेंट, कि आपकी कोई भी API विद इन 200 मिली सेकेंड सर्व हो जानी चाहिए, राइट? तो अगर आप एक डेटाबेस यूज करते हो, minimum latency that you will get from a database call will be 50 millisecond, right? Then you might be, let's say, doing 3 database calls, आपका 150 millisecond वहीं पे हो गया. Then you might be doing some internal processing in Node.js code या any code. Then you will send that data over the network to the client, right? तो network में भी latency आएगी. उस बंदे का 2G नेटवर्क हो सकता है, तो वो स्लो डाउनलोड करेगा, राइट? आपका पेलोड साइज काफी बड़ा हो सकता है, तो उसमें काफी डिले हो सकता है, राइट? तो लेटेंसी आपको 200 मतलब 200 मिली सेकेंड के अंदर अगर लानी है, तो आपको कुछ ना कुछ फास्ट प्रोसेसिंग सिस्टम्स चाहिए जो आपकी लेटेंसी इंक्रीज ना करे, राइट? एंड यू माइट ऑलरेडी नो अबाउट कैश, कि कैश इसी तरीके से काम करता है, दैट यू ट्राई टू कीप द थिंग्स दैट यू नीड क्लोजर टू यू, राइट? अगर आप कॉलेज में देखोगे कि लोगों के कपड़े सारे चेयर पे पड़े रहते हैं, बिकॉज दे नीड फास्ट एक्सेस, राइट? सो दे डोंट वांट टू गो टू देयर क्लोजेट एंड टेक द क्लोथ्स आउट, चेयर पर रखे, फास्ट L1 कैश है, उठाया, पहन लिया, चेंज कर लिया, वहीं पर पटक दिया वापस, राइट? वो अपना कैश हो जाता है. तो when you want to bring things closer to you, that's cache, right? You will have multiple levels of cache. So this is where in-memory database are present. So there are few things that these databases avoid. Like first thing is buffer pool management. Do you know about buffer pool? What is a buffer pool? No idea, right? So it's also a cache inside database. Okay. So if you see, in database, things are stored in disk, right? Then if you query something, it goes first to the index. Index is in memory, right? Then you found some keys in the index. Let's say you index on 2 keys. You can bring those 2 keys. But if there is any other field inside your query which is coming out from the database, then it needs to touch the disk, right? So it will first go to index. It will check if all keys are in the index and you are getting only those 2 keys, then you will get the full data from the index itself. That is called a covered query, right? Fully covered query. But if you find any more fields which are not in the index, you will have to touch the disk, right? So how many pages or blocks of pages you can keep in your database, that is buffer pool, right? So buffer pool is also a cache. So you get some page from disk, you keep it in buffer pool as a cache, right? If more queries are coming and that page is not getting queried again, it might get replaced by some other page inside the database, right? So that is buffer pool. Since the database already is in memory, you don't need to touch the disk, you don't need a buffer pool, right? So that a lot of processing that is happening inside the database, you can completely avoid it. So that is buffer pool. You don't need buffer pool in memory databases, right? So buffer pool is a cache inside database itself. So you have a, let's say, some memory fixed that you can say that I can pool 80 GB of pages inside my database. Let's say your database is 2 TB. You have 80 GB of buffer pool. So 80 GB of database records you can keep in your buffer pool. Got it? Sorry? Views you have in some sort of a different layer, but it's the logical thing. Views are logical thing. This is actual implementation inside the database. It's done by the database developers that this is how buffer pool is implemented. And there might be very different algorithms other databases use, right? Postgres might be using a different algorithm. And it's the engine, database engine that implements it. So MySQL, there is a InnoDB engine, right? So there are multiple engines that have been developed over time and they maintain buffer pool. Okay. So it's implemented by the database developers. Views you can do on the application side, or DBA can create materialized views just to get your data faster, right? That is a separate thing, but it's the actual implementation inside the database, right? Any more questions on buffer pool? It's based on your workload. If your workload is like you are making random queries at a time, so it will just keep replacing whatever you want, right? And if you're carrying the same data again and again, the buffer pool will be there, right? Because it will keep caching the same there, and that pages will get directly served from that buffer pool, right? So you will have very fast querying from the database itself because it doesn't go to the disk all the time, right? डेटाबेस की इम्प्लीमेंटेशन है जो डेटाबेस इंजन ने एल्गोरिदम लिखी है कैश क्लियरिंग की, वही हैंडल करेगी इस चीज को. आप मैनुअली नहीं कर सकते. देयर माइट बी सम वेज विच यू कैन ट्यून द एल्गोरिदम. लेट्स से यू हैव सम कर्नल पैरामीटर्स ऑफ द डेटाबेस इटसेल्फ, so they give you a config file or config parameters that you can tune, like how much GB you can have, what is the algorithm that you can use for buffer pool management and all, right? So it all depends on database provider. If they provide you that much of configuration, you will be provided with that, right? If database developer doesn't provide you configurable buffer pool management, then you won't have any way to do it, okay? And yes, yes. Depends. So it also depends on how your buffer pool is managed. So let's say if they say ki if buffer pool is full, don't cache anything, just return from database directly. So there might be some kind of algorithm like that. All databases, either buffer pool or some implementation which is which works in similar way. So basically database also needs a cache to serve the queries, right? Because you can't give a very predictable performance to all the queries. Because so let's say in MongoDB, it's called a working set. Okay, working set is basically what data you have. So I'll just give you an example. Let's say uh, you have an app. Let's say you have some dating app. Let's say, right? And as the population grows and goes beyond 18 age, they start installing dating apps, right? Now, as they reach 40 age, they start deleting the app. So every time your customer base is new, right? And since the customer base is new, what you want to keep in the working set needs to change to the new customer, right? If some customer is using your app every day, you would want that customer's queries to be served from the cache directly, from the working set. Working set is the data that you want to keep in memory closer to basically your application, right? If your working set was fixed, let's say 40-year-old customer who has already left your application is not there. Now you still have that user's data in your working set. What is the need of it? No need, right? You need to keep replacing it with the users who are actually using your app. Got it? So you need to keep replacing that data with the fresh queries and the users which are actually using your application. So you need to keep the data which is actually getting used in the working set or in your buffer pool. Yes, yes. So you don't want to keep very stale data in your database. It will not help you in any way in improving your latency, right? Any more questions? Database will handle. Basically, there is a concept of dirty writes, and so you must know that when you write to a record, it has to update the index as well, right? So let's say you updated some data in your database, so it will update index as well, that this value is updated, right? So if you are updating in data, then index, then you won't have any stale data, right? And if a page is updated, then it will definitely get it will definitely get pulled to the buffer pool already, right? And let's say you're just writing, then you might not need to get it in buffer pool. For the next query, it will get updated data because there will be a marker in the buffer pool that this page has been updated, or this page which is currently in the database buffer pool, it's dirty page. So you should replace it or just fetch it again from the disk, right? Yes. So whenever you update, let's say you have 10 records in buffer pool. Now you update one record. So database might add a marker that this is a dirty page, right, in buffer pool. So if another query comes, this is a dirty page, just go back to the disk, bring the fresh page, right? So these are like ways database handle these things. Any more? Yes. Mhm. Yes. So I will go through multiple layers of caching. So I think everyone is interested. You can implement this in somehow mimics a database, right? So if you just look at database, you are just querying something, getting some data. If you open an application, you are doing the same thing. It's just that the interface is very humanly, like humans can use that. So every application that you are trying to build will in the end implement similar functionality to a database. So let's say if you go to your Facebook and you check your profile, it's just a button clicks that you are doing, but whatever is happening, it's coming from some database, right? If there was no Facebook interface, you can do the similar thing from SQL query, right? It's just that the application is the something that developers are building so that mass of people can use it, right? So every functionality that you will build, databases might have already built those functionalities, right? And your application will definitely mimic some or other functionalities of database, right? Any more questions? No. Okay. Locking. Does anybody know about locking? No. So locking is basically when you update a record, you have to lock that resource. Okay. So locking also happens in a very weird way. So let's say you are updating a record. So you might think that only one record or one record in your OS table or page table, whatever it is, only one record is logged. No. So in disk also there is some sort of blocks, right? So let's say if your 4 records are placed in a single block in disk, right? It might be possible that one block is completely logged by the database, right? So if you are updating one record, 4 other resources records might also get logged, right? So since it's in memory, you don't need to take a lock. You are just operating on a single key, so it can avoid locking. So locking also adds to the latency. So one resource is locked, you cannot do an operation until that resource is unlocked by the other operation. So let's say you have a microservice running, it's trying to update a record in your database, right? Until that record is updated, other query which is updating the same record in the same disk block, that record will not get updated. It will keep waiting in it loop until that resource is free, and then it will do that. So there might be a latency for updating those records. So it can avoid completely that, right? Yes. Yes, yes. So we don't even have to implement locking because it's single threaded. Mm-hmm. So yes, in some way, but there are ways to avoid that as well. So there are some algorithms which will check like which update is the latest. So they will apply that update, right? So there are multiple ways to avoid locking, optimistic locking and all those things. But yeah, it, that goes into deep into how the database is implemented itself. But as a application developer or in normal software development, you won't face those kind of issues. But you should be sure like which database you are using, what type of workload they can support. If some database is multi-threaded and they are saying that you won't face any issues with uh, wrong writes, so it might not be the way, right? So you might need some locking on the application side then to prevent some bad writes happening, right? So in a way, you will have to prevent that from happening in some way or the other, right? It's the same thing. So database is providing you uh, a, what do you say? It's saying that it will not do any bad write because it's single threaded. It will do one write at a time. So you will not face any issues with wrong writes, right? If database is saying that, then it's okay. If database is not saying that, then you will need to do that in application, right? So you are doing the same thing again. Okay. Then we come to index updates. So there are no indexes to maintain. It's all in memory itself. So everything is sort of an index, right? Write ahead logging. Does anybody know about WAL? You must have heard it. Yes. So any file write operation, you know it's very heavy, right? So if you are appending to a log, that adds to the latency, right? And it's not just you're appending to a single log. So let's say if you have a master replica setup and you have, let's say, setting that whatever write that you are doing in your master database, it should first get replicated, then it should get acknowledged. So it gets write to master log as well, replica log as well, then an acknowledgement from replica to master that this record has been written successfully. Then you just say that to the application, yeah, this write is complete. So this logging also can be prevented because you don't need to do any disk write. Everything is happening in memory. Yes. So persistence is happening in some other ways. So it happens in asynchronous way. So there are multiple ways to do persistence in Redis. One is a RDB file, Redis database file, which is basically it takes fork of the whole memory, right? So let's say if you have 2 GB data in Redis, it will take fork of the memory. It will create a small file, compressed file, which you can use to restore the database. There is append file also. So you can uh, keep appending file asynchronously in the background. So there will be a separate thread which will help to do that. So in previous versions of Redis, older versions of Redis, main thread was handling all this, like forking and creating the RDB file, also appending the file. If you have that configuration, so you can configure your Redis. Either you want append file system or you want RDB file system, right? So if you want to configure append file, so you can specify how fast you want to append, every second, every 2 seconds, every minute. It's up to you, right? So they provide that configuration so that your application has like as per your application, you can do that. So if your application requires that every second your data should get logged, you can do that. If your application does not require that level of persistence, that you can do without some data miss, right? There might be, let's say, 1 minute of cache that can go down. You are okay with that, then you can just use RDB for 1 minute, right? So it all depends on your workload and how you are using Redis. So if you are using Redis as pure cache, so whatever you are storing in your Redis is already present in your some database. Let's say behind Redis, there is a MySQL where you are fetching the data and you are putting it in Redis, some keys, some data. But if Redis data gets lost, it's still available in MySQL. Then you can just don't do that kind of level of persistence, right? You can afford to lose Redis, right? So in most of the cases, you implement things in a way that you can afford to lose Redis anytime. Uh, yes, so we keep doing that. So it depends. So let's say in older versions of Redis, there was an issue key. If you enable the RDB file forking and then saving, it will increase the latency of Redis because it's happening on the same thread, right? Now, I want my system to not face any kind of latency. So I will just shut down that. Like I will stop the RDB file saving, right? Because it's the demand of my database. What I will do is I will keep the RDB file save on my replica because most of my writes or reads are served from master, let's say, and then I will just keep replica saving on the basically RDB file saving on the replica. So if anything happens to the master, my replica will become master. Then I will be able to serve from that, right? So there are ways to like tune your configuration in production, right? And it will only be available if you self-host your databases, right? You'll get to know a lot of things. So disk seek, I think everybody knows, like whenever we are touching disk, we'll face issues with latency. So it will avoid that, right? So compromise, I think we have already discussed. There will be a loss if you have configuration like for 3 minutes, your RDB file did not get created. So you might lose that 3 minutes of data, right? So it compromises on that. Consistency as well. So you might lose some writes if master fails. And let's say it takes 2 seconds to replica to come up. So you will fail some writes. Okay. So these are some latency numbers. I think you might have already seen those. So I'll just share the like these part. like just a reference how fast the caches are. So in one CPU cycle, if you just take 0.25 second, L1 will be twice of that, L1 cache 0.5 second, and L2 7 seconds. And if you just come to main memory, so it will take 1 minute 40 seconds. It's just a reference, right? And if you go to disk, it will go to 1.7 days, right? So this is the actual difference from 1 minute 40 seconds to 1.7 days. So if you are serving directly from memory or you are going to disk, this is how big the difference is, right? So it is not very visible in nanosecond and microsecond, but here it is quite visible how big the difference is, right? And if you had hard disks and it had to rotate that uh, a disk, then it will take very, very long time. Okay. So this is basic topology of Redis, like how you can deploy Redis in production. So there are cluster, standalone, and then Sentinel. Right? Cluster, you need minimum of 3 nodes, right? 3 master, 3 replica. Right? This is mainly for what do you say? Leader allocation and all. Right? Your configuration should always have voting in a way that it can decide which is the master node. Right? And similarly, standalone, you can have single Redis. You don't need any sort of, let's say, persistence or durability. You can use a single Redis. If it crashes, we just go back to main database. This can work. Sentinel is like one master, one replica. Okay. In cluster, the keys are sharded by a hash, right? So keys will automatically get distributed. You will have a single client that can understand the topology of Redis. So if you write a key, it will automatically go to the correct shard, right? You don't need to manage shard, which shard you are sending the data to, right? Redis will all automatically handle that. So, yeah. So it depends how you want your application to work. So there is configuration in Redis that you can make your Redis unavailable if one shard goes down. And there is configuration also available. If you want your Redis to still serve the data, you can still serve. Keys will be gone, right? So if your shard goes down, you can immediately do reshard so that your keys are resharded to uh, other nodes. Yes, resharding is a costly operation. For some time, your application will face issues like key move to other shard, key move to other shard, right? Usually, this we do not do in production, that one node is down, that then you can keep serving. We just shut the whole system down, we recover it quickly, and then we bring the system up. Because if you bring some shard down and it's not a pure cache use case, then your application might face much more issues, because there might be transactions happening which are incomplete records, or a lot of things will happen in your system that even you won't know, right? And when a system becomes so big that even you don't know what is happening inside your database, then you should basically take a downtime, relax, recover the system, then make it back live. Otherwise, the effort to recover your data is too huge, right? It's better to have clean records in your database, right? So these are some of the use cases of Redis. So these are not the all of use cases. Redis is basically growing very quickly. So a lot of use cases like Kafka, streaming, vector databases are also covered by Redis. So, but here, like basic use cases, which most of the organizations are doing, right? First is like data storing, volatile cache, page caching, session management. Leaderboards is a very good use case, right? System control and coordination, distributed locks you can use, right? Preventing race conditions, server allocation, load balancing, right? Very unique use case. And real-time operation as well, like rate limiting, rate limiters. Lot of rate limiters in production are supported by Redis now these days, right? In a lot of organizations. And asynchronous processing. So background jobs you can schedule with Redis, and PubSub, I think you already know, right? So these are like very basic data structures. You might even not need the databases which are here, right? Very specialized use case, you might need bitmaps or geospatial index if you are doing that kind of work, right? But a lot of use cases are served with these 5 data structures, right? So first use case, let's say page caching. So you might be able to see like whatever pages you see on Instagram or any social media site, you can cache the whole page. No need to worry about like caching a single image or something. You can cache the whole page. It will directly get served from cache, right? A lot of applications do that. And at a very high scale also, you will be able to handle these things, right? And obviously, this cache will also be limited. So how many keys you want to cache, you can limit. So there is a max memory configuration provided in Redis. Let's say you want a Redis separately just for caching the pages. What you can do is just put a max memory limit. So if the pages which are not being accessed recently, they will get removed, right? So most used pages that can be cached, right? So very simple implementation here, right? You can just use profile. You can get, if already cached, you can return from the cache, right? And basically, if it is not cached, just bring it from database, right? And then set on your Redis, right? And usually we set data in Redis with a expiry, right? So that our database cleans itself. We don't want to like manually remove keys later on, but I have done that in past. There was a case when we deleted a lot of keys which did not have expiry. So database size came back from 150 GB to 18 GB, right? So always try to use expiry. It can be any type of expiry like 7 days, 1 month. It depends on your workload, right? So let's say if your user retention is 7 days only, why do you want to cache it for a year, right? Just cache it for 7 days or 3 days, right? So always set in your Redis with expiry. That will be very good thing to do. हम्म, क्या चीज दोबारा बताओ. हाँ. हम्म. Right. So what will you do if your page is getting updated very quickly? What will you do? Whenever let's say this page creator or page manager updates the page, we can rewrite the cache, right? So we can just remove the cache. It will get again updated from database, right? Yes. So it will not be logic of your Redis. It will be your application side logic. If a write request come to the page, you just remove the cache from Redis. The new fresh cache will come, right? So only one single call will get affected, will go to DB. Then further subsequent calls will again get served from Redis, right? So we usually do this. We just remove the cache whenever we are updating. Got it? Any more questions? I think fairly simple use case. बार बार like हो रहे हैं, right? So here what I'm showing is a very simple use case, right? So Instagram is not implemented like that. Okay, so every use case is served by a different database, right? It is not a very simple implementation, not a very simple app as well. uh, every like might be served from geologically distributed database, right? Some information might be coming from let's say Canada, some information might be coming from Delhi, right? uh, and these likes count might not also be consistent. So you might see some number of likes increased somewhere. You might not be able to see same number of likes on your phone as well. So it's distributed, eventually consistent. It will get replicated to multiple databases and then served from there, right? So bigger organizations use a very high level of asynchronous computation. So it's not just a single write that you can do from one microservice. So you might have seen some latest posts about Netflix. They implemented a distributed counting microservice. So just maintaining the counts at such a high scale is a very, very big problem, right? So I'm showing you a very basic idea how to use Redis, but these are not implemented in such a simple way. Got it? Cool. Hmm. Right. He might not be. Right. Okay. So let's come to like Flipkart. You must have seen that whenever you add a product to your cart, you might not even be logged in, but it keeps that session like cart information maintained in your browser. Like they save it in cookies, and they might even save it on server side as well, because they need to convert that transaction to a particular user as well, right? So they keep it on server side as well. They keep it on cookies, cache, all those things as well, right? I'm not sure about exact implementation, but there are some use cases where you want to do that, right? So there are a lot of applications which don't require authentication, but you need some metrics like how many people are adding to the cart, right? So let's say some business guy comes and say like how many people are adding to cart but are not logging in and then going to make a transaction, right? So tuning all those metrics require some server side computation and saving, right? So you might be wanting to save that in cache, because this is not a real use case that you might want to save in database, because user might delete browser, delete cache, whatever they can do. So you can just keep it in a cache, remove it whenever you want, right? Let's say you can keep it in cache for 7 days. Like, how will we manage sessions? So that's what I'm saying, that uh, for every session that you are getting from any device, you can have some sort of unique identifier. Let's say device MAC address, right? Device IP address, right? A lot of details combined can uniquely describe that where this request is coming from. And then uniquely you can say that this session is being saved by this user, right? Right? And you might be even able to map it to actual user inside your database, right? So a lot of things happen at a large scale that you can derive all these metrics in some way or the other. Okay. So very simple, just use a session ID. Session ID logic, you can implement in any way possible, whatever your application logic is. Then for that particular session ID, you can set cart entries that I have added this cart with this much of quantity, right? You can keep that in cache. Got it? Very simple use case, but this is the use case of cache. This might not be just Redis, any kind of cache database you can use to do these kind of things. Okay. Then we come to like this Hotstar. You must have seen like any cricket match and all. They show you how many people are watching, right? So that's a very I think important number and metric which shows the trust in the platform, right? If they did not see this, then the hype would not be that real, right? Is if people see that 5 crore people are watching, if they just open the match and they know that match is going on, but they don't know what is happening in the match. If they see that like 25 crore people are watching, then something interesting might be happening, right? And if you see like it's a World Cup match and 50,000 people are watching, not a very good match to watch, right? And a lot of things happen in platform when cricket match happens, right? Like Dhoni getting out. Okay, so I think Hotstar also gave a very good tech talk regarding how they scaled to 25 million viewers, and they even showed the what do you say graph of number of users increasing, and when Dhoni got out, all the viewers left, right? And when all the viewers left from that viewing screen, all their other services started crashing, because in every screen there are tens of APIs, thousands of APIs that might get hit, right? And suddenly, so you might already know about auto scaling that happens in microservices, right? So if a user is redirected from one screen to the other, and that other request is served by some other microservice, and that is not currently scaled to that particular level, so every scaling happens slowly, right? So if you immediately like Dhoni gets out and all the users, like 5 crore users go to homepage will crash, because that homepage microservice was not scaled enough. and it will take time to scale it up, right? So preventing those kind of use cases, you have to be doing a very high level of planning. Like this might happen, like Dhoni can get out at a very crucial time. Okay, so you have to pre-scale your services to handle any kind of load. Pre-scale your databases. You have to do performance testing on your databases. Will your databases will be able to handle that kind of load and all? So uh, these numbers matter a lot, and maintaining these numbers, like I just told you, like big companies need to have a distributed counting services itself, right? But if you are making a very simple app to show videos like how many viewers are watching, you can just use Redis, right? So very simple thing, like whenever a user joins on your web page, you can have a socket event or any API call which can just increment the count. And if a user closes your tab, you can just decrease the count, right? So very simple use case, but yeah, at a scale, things happen in a different way. Any questions? Redis server crashes. So when the application server crashes, usually application servers don't crash, but yeah, they can crash as well. But databases are the one that fail. But application servers crash, the app starts to fail, right? Yes, yes. So let's say this track active viewers was deployed only on this service, which is basically handling the count management of viewers for a particular match, right? Let's say Hotstar has a separate sports service which is handling all these counts. But this might happen that this decrement of the viewers can happen at a very fast pace, and your Redis might also crash, application might also crash. That's why I told you, like these things happen asynchronously. On the application level itself, you can introduce batching, right? So let's say every application container will start to increment a in-memory variable. And let's say at every 5 seconds, it pushes that, let's say 20 viewers have joined to my server, right? Let's say that is a socket server, which is handling web sockets. So it will keep incrementing the counter for 5 seconds. After 5 seconds, it will push to Redis +5. Don't do +1 at every socket connection. Do it in after 5 seconds, right? At very high scale, you might even do that for 5 minutes as well. Because at that level of scale, you don't want to do that kind of computation directly on Redis. You can basically avoid doing that level of computation from microservices. So when the scale down happens, application won't crash, but yeah, the database can crash. But at scale up, applications can crash. Sharding. So in this case, so something about shard. I think there is a problem called hotkey, right? So let's say for a particular match ID, there is a single key which is in getting incremented, right? So that key might be present on single node, right? So if a lot of writes happen on a single node might fail. Okay. Yeah, master might fail, then replica will come up. But let's say load is still high, replica might also fail. So your whole shard can get down, right? So it might be possible that this counting can be split into multiple shards. Let's say 10 keys are handling, you have 10 shards, you are handling 10 keys and then summing those up and then maintaining that, right? Yes, मतलब यूजुअली ऐसा होता है जब मास्टर डाउन जाता है रेप्लिका तुरंत अप आ जाता है. ठीक है, अगर रेप्लिका भी डाउन जाता है देन वी हैव टू शट डाउन द रेडिस कंप्लीटली एंड बेसिकली एप्लीकेशन का ही डाउन टाइम ले लेते हैं. ऐसा होता है. बट जनरली इतने बड़े स्केल पे these things are distributed to multiple servers, multiple databases, and there is also replication. So replication as in this replication, not this application, but disaster recovery replication. So let's say if you have a Redis server with 12 nodes, uh, let's say 6 master, 6 replica, you will have a parallel replica made, which is copying the database in real time. And in case of disaster, you will have a kill switch that if your this database dies, instantly switch to the other database. That is usually done by like stopping the instance directly. You will have a route in DNS. You can change the background URL of that DNS that all the further requests will go to the replicated database, which we have kept for disaster recovery. Okay. So a lot of measures are taken to just prevent any kind of cascading failures. Okay. All right. So we have done with session management and this count as well, right? Got it. So leaderboard, I think, can anyone suggest like which data structure we should use for leaderboard of Redis specifically? Yes, this can be maintained in real time and in some batches as well. Let's say every 1 second or every checkpoint in your race, you might want to update the leaderboard. So there are these data structures. Can anybody like tell which data structure should we use? Sorted sets, right? Uh, uh, okay. Has anyone used it before? You have used it. Good. So sorted set is basically it maintains a score. Okay. So for every key that you insert, you add it with a score. Okay. And you can get the top 10 items from that sorted set. Okay. And you can sort it with scores in reverse or normal order as well. So, and this you can keep maintaining. So let's say if you have a lot of drivers which are running in a race, and at every checkpoint you want to update the leaderboard, so you will just send another z ad with the latest score that the user have. That score might be a combination of obstacles that they have seen or how much further they are in the race, right? So sorted set is heavily used in leaderboards in a lot of gaming companies and all. So in some sort, leaderboard is directly served from Redis. You don't need to have a database. So let's say if you need to serve it from database, what will happen? Too many updates, right? And these updates go to disk. And also, in the end, when you are fetching, you might be doing in-memory sort of the database, right? Databases have limit how much data you can sort in memory. If they are not able to sort in memory, then you will have to do sort in your application side. So you will have to, let's say, every container will do that in memory sorting, then replying to the client, right? A very difficult use case. Otherwise, you will have to do some sort of Hadoop system where you are computing all those things and then you are creating a leaderboard. You might need a very big system just to create a very simple leaderboard, which can be handled by Redis, right? And a lot of systems, if you want to build for low latency, just make it event driven, right? If you're keeping it event driven, you can use very lightweight database like Redis. But if you need to keep it in database and then do some batch processing and then generate leaderboard, it will take a lot of computation to do that, and a lot of power, computation power that you will require. And it's not very efficient, and you might not be able to build it in real time as well. Here you can build it in real time. Got it? And if your leaderboard is accessed by a lot of users, you can just separate out your Redis just for this particular use case as well. And it's very good idea to just separate out your Redis for use cases because it's very low compute, but it supports very high number of transactions per second, right? And it can easily scale up to 50,000 per second request, right? It's a lot of computation power. Mhm. So you can just make another leaderboard, right? You can have separate use cases leaderboard. So let's say you have 10 types of leaderboard with different conditions, right? Different filters. Let's say you want to make a leaderboard for only Gujarat region. You want to have a leaderboard only for Delhi region. You can make separate sorted sets just for that, right? Let's say you have a different sorted set for Gujarat, different for Delhi, and then you have a global leaderboard. Just keep it in separate keys. Very easy to do that, right? So any use case you want to do, just need some creativity. How do you separate the workload, right? Any more questions on leaderboard? No. Okay. So this is a very simple use case. So whenever you are updating, so you can keep, like, let's say if you want to definitely show some users in the leaderboard, you definitely don't want to show like too many users, right? So you just keep adding the rank, and you just remove whatever is below the requirement. So if you want to keep 1,000 users, you can just remove rest of them. So your key size will also be small, and your data structure size will also be very small and very efficient computation, right? One another use case is preventing the race conditions. So you might have already seen, like when you book a ticket on flight or any sort of booking platform, it might be possible that somebody else is also doing that, right? And you don't want two transactions to succeed while you know that only one can go through, right? So then what will happen is, if two transactions occur, like payments occur, but only one was booked, the companies will have to generate a refund and all those things, right? Just to prevent all those race conditions, we can use Redis as a distributed lock. Okay, so whenever a payment is happening, you can take a lock. Let's say you take a lock for 2 seconds. Now the payment is getting processed. So you take a lock, and lock is just creating a key. And if that key exists in the database, you won't allow any other code to process. So let's say I have a 10 application containers, and I have 10 requests coming to the booking service, right? So what will happen is, every application can make request. But let's say one request was 10 millisecond ahead, it will acquire a lock. Okay. And once that lock gets acquired, every other request will check if this key exists. They will not go through, right? They will just abort the transaction then and there, right? So all other 9 containers can get blocked directly just by using Redis locks. Okay. So very good use case, and we have a lot of libraries that we can just use to do the lock acquire. And Redis internally can use Lua scripts to do multiple operations in an atomic way. Okay, so these npm packages, redlock or redis lock, they internally have Lua scripts written, so they do 2 or 3 operations in a single transaction, right? So you don't need to do 3 operations one by one. So there might be an issue with the locking if you use 3 separate operations from application. So you send one single operation in Lua script, and everything happens automatically, right? So here you can see, like, you can acquire a lock for that particular bus ID and that particular seat number. And once, so every call that comes to this function, it will get blocked here itself. So if any other container comes in and tries to acquire a lock, the lock will not get acquired, right? So it will get blocked here. It will not even go down. Okay. So this is how the Redis locking works. Yes, right, possible, but you still prevent a lot of mishappening. So payment usually gets processed very quickly. तो ये इसके लिए प्रिवेंट करने के लिए, जब एक्चुअली पेमेंट प्रोसेस हो रही है, राइट? आपका पेमेंट चला जाएगा, बट दैट एक्नॉलेजमेंट माइट कम लेटर, राइट? तो आप इस लॉक को रख लो बस इस ट्रांजेक्शन के लिए. आप यूजुअली इन एप्लीकेशन, इफ ए पेमेंट इज प्रोसेस्ड, यू मार्क दैट सीट एज बुक्ड. तो डेफिनेटली उसके बाद तो कोई और बुकिंग कर भी नहीं सकता. बट अगर वो पेमेंट बाद में जाके फेल हो गई, दे विल बेसिकली अनलॉक दैट सीट, राइट? But usually in systems, you want to prevent for certain amount of time. So let's say it depends on how the application is performing. If let's say they do it synchronously, they will wait for the payment success. So you might want to wait for 10 seconds. If they do it asynchronously, you don't want that API request or function to get blocked for the very long time, right? So you can have it for very small time, 2 seconds as well. And if you do it synchronously, you want to wait for the payment success to happen, you can wait for 10 seconds as well. Got it? Okay. Then load balancing. Uh, does anybody have any idea like how can we do load balancing with Redis? Multiple instances. So load balancing, think of as a application. So you must have understood the concept of load balancing. But if you want to build your own system of load balancing, how will you do it? Very simple logic. Right. Nginx kya karta hai? It's a reverse proxy, right? It will just pass any request to the upstream server, right? What we can do is we can inject Redis code in Nginx, right? So there are Nginx plugins which can allow you to call Redis. Okay. So let's say I have 10 gameplay servers and I want to do game allocation. Okay. So let's say uh, I have 10 players. Let's say I have 4 players on a particular table. Let's say I am playing a card game. I want 6 players on a table, let's say. Okay. Now I want that gameplay to happen on a particular server. For the single table, I want that to happen to a particular server. I don't want my players to be distributed among different servers because all the computation that I want to do should happen on a single server. So what I can do is I can inject that logic inside Redis that for this particular table, this is the gameplay server that is already allocated. So if a user comes to this Nginx, I can check for this UID, user ID, what is the playing table ID, right? And I can check where this playing table ID is hosted. I know the IP address, I know the port. I will directly connect that user to that particular server, right? So from directly Nginx, I can do load balancing. Another kind of load balancing is just how much load I want to give to a particular server, right? I can have a sorted set which have a score. Let's say on a particular socket server, I have 100 people playing. And on other server, there are 1,000 people playing. Where do I want to send my users? 100, right? Because I don't want to overload the server, which is already having a lot of users. So what I will do is I will sort the servers by score. So for the lowest score, I will just send my user to that particular server. Okay. So you will have a Lua script on the Nginx itself, which will find all this information about all the servers, how many users are there, what load is running on that server, and you can redirect the client. Okay. Uh, Very simple use case. You can basically keep this information. This server is having this host and port status is active, right? These information you can keep in Redis, right? It's a very low latency database and it's a central database. You can keep that information there, right? And if you want to register a server, you just add it to a sorted set, right? And another key is for that particular server. And then least loaded server, I will just get the record with the minimum score, and then I will increase the count that one user has joined to this server. So my server is now loaded by one more user. Okay. And if a user gets disconnected, we can decrease. Okay. So another use case is API throttling. So you can rate limit. So I just told you about like users coming back to the homepage. So to prevent that from happening, services from crashing, you can do rate limit. So users might be able to see some sort of error codes that some issue with our service, please try again, right? So what that when that happens, there is some kind of rate limit happening on the backend, right? So you might implement very simple rate limiter on the Node.js microservice itself, or you might have a distributed rate limiter as well, which will do the rate limiting for the whole application, right? You can do rate limit on container plus global as well. Okay. So that can also be done by Redis. right? So you can have a counter that this counter is increasing. And whenever that counter, active request counter reaches beyond some number, you can basically reject requests, right? So very simple rate limiter. So whenever a request is coming, you can just increase that active requests have increased. And if number of active requests are, let's say, more than 1,000, you can just drop that request, right? And very simple use case. So this is fixed window rate limiter, where you are maintaining only a fixed window, like these many active requests can happen. But there is another variation where you can use sliding window rate limiter, like from this minute to next 10 minutes, how many requests I want to serve. That can be implemented using sorted set, which you can explore later. But this is a very simple use case that is done. And there are a lot of packages are also there which you can use to implement rate limiting, because whatever generic solution that you are trying to implement, somebody has already thought of it and they have built a open source solution and used the best practices possible and made a generic solution to all the use cases, right? So you can use that as well, but you should know how that might be implemented in Redis, right? And pub/sub model, I think you have done very basic pub/sub, like you send a message to a particular Redis channel, then some other Node.js process might be subscribed to your channel that might be receiving the messages. But at a scale, there might be a very different type of implementation that you might want to do. So you might not want your clients to be connected to Redis directly, because there is some application level logic you want to implement, right? So let's say you have a socket server, which is handling the WebSocket connection directly from the user, right? And now that socket server needs to reply in real time, right? And how Redis can be used here is the socket servers will be connected to Redis, right? They will be subscribed to Redis, and the socket client that is connected to the socket server, that will receive message directly from socket server. Okay, so each socket server will have their own channel, right? And whatever users are connected on that socket, those will be subscribed to that particular channel. Okay, so only the users which are connected to my server, I will only send those messages out, right? And on this Redis, I might be publishing my messages or notifications from some internal service, let's say notification service, right? In real systems, there might be possibility that a lot of writers are there on the Redis. It might not be a single service, but usually the best practice is to keep your infrastructure separate for a particular microservice. So let's say if you want to keep your notifications scalable, you have separate out notification service, and whatever socket use cases are there, notifications, real-time notification, you separate out your infrastructure completely for this pub/sub use case, right? So it all depends how much the scale is, how much you want to separate out things. And pub/sub is a very heavy use case, CPU heavy use case, right? So usually Redis is in-memory database. It is more suitable for memory heavy processes, right? But pub/sub is the case where CPU comes in, right? So let's say if you have a channel and you have 10,000 subscribers to it. So what will happen is on that 10,000 subscribers, a loop will run, and in a loop, they will push message to each of the subscriber. So that's a very heavy CPU computation, right? So in usual Redis deployments, usually the pub/sub use cases is separate on a separate infrastructure completely, right? And you might want to implement pub/sub in a way that number of subscribers to a particular channel is very less. Okay, so let's say on this socket server, I have 10,000 clients connected, but I should not receive 1 million messages from here, Redis, right? I want to get only messages which are required for these 10,000 clients, but I don't want all the million messages, because I will basically reject a lot of them itself. But Redis have to do a lot of work internally just to publish those 1 million messages to a particular socket server, right? So even though Redis was used to be in memory, but it has CPU heavy use cases as well, right? So whatever functionality you see in your databases, always try to think how this might be getting computed inside database, how internals might be working. Is CPU getting used more or memory getting used more, right? Or the network is getting used more. So let's say there might be a possibility that your payload size is too high. So your Redis can return very fast, but your network will get choked, right? A lot of use cases come like where latency issues are there. You need to check on all the cases, like where if the CPU is getting blocked or memory is getting blocked, or you are breaching network issues, right? So even in the cloud, there is a limitation how much network out you can have from a particular server, right? How much network in and network out, that is also limited, and everything has a cost. If you are doing 10 GB per second from a particular server, that will cost you a lot. If you are doing only 1 Gbps, that will cost 10 times less, right? And in cloud deployments, everything is distributed in multiple zones. So if you are doing deployment in a single zone, you will have no network cost. But whenever you do any kind of distributed zone deployments, multi-AZ deployment, you say, there will be a cost of network from one zone to another. So let's say if you have some server in Hyderabad and you have some server in Mumbai, and if you have master in Hyderabad and replica in Mumbai, then just the replication cost will start to increase. And if you have, let's say, 20 GB in your Redis and it's getting replicated at every second, so your network cost will keep increasing, right? So in real world, everything has a cost. So if you are going in tech, you should think about everything, not just DSA or Algo or Next.js or front end. Just think of computations, right? Whatever it is that you are doing, even if you are writing a character from your keyboard, that has a cost on your computer, right? If you are writing 10 strokes in a second, that has a cost. Your power might be increasing. If you are playing a game, graphics are there, there is a cost, right? These type of costs are seen in real world as well in companies when things are running at scale, right? You might be plugging your charger and you are running your laptop. You are saying that there is no cost, but your electricity bill might be increasing, right? So always think of costs and use Redis for optimizing your costs and simplifying your use case, simplifying computation, building event-driven systems, right? A lot of things. And you can save a lot of time as well and get a lot of creative as well, right? So any other questions you can ask? It might be related to Redis or any type of question that you might want to ask, you can ask now. So it depends on the workload. So I told you that Redis can scale up to 50,000 requests per second, but there are claims that it can go up to 1 million requests per second, but it depends on what kind of workload is. If I am doing get set, it can definitely scale up to 50,000 requests per second. Very simple, a very small server. But if my payloads are different, my workload is quite different, right? It will fail at 20,000 requests per second, right? If let's say scale is like the payloads are too huge, so it might fail at 5,000 requests per second. So I'll just give you an example. So let's say if you have a 2 KB payload that is coming out of Redis on every operation. So Redis is single threaded, it has a queue, right? You push your command to Redis, it goes into a kernel queue in your server, it gets pushed to Redis queue. Redis maintains an internal queue. Then it gets processed, command gets processed inside Redis, then it comes out of another queue. And those queues are maintained by operating systems as well. So operating systems will also face some memory pressure and the network will also get choked, right? So network choking might even become bigger problem than just your Redis processing, because sending that big amount of payloads, you will not be able to do 50,000 requests per second. Even if you are doing that 50,000 requests per second, it will be of a very high latency, right? So how you use your Redis depends how many transactions per second you can achieve. But Redis is single threaded, right? You have you have cluster. So I showed you 3 master, 3 replica. You can go up to 500 master, 500 replica. But definitely you don't want that to happen, that you have such a big cluster, single cluster, because the point of failures are too high. Either you go into microservice architecture and split your Redis clusters, right? You don't want a very big cluster. So Redis queue that I was talking about was internal implementation of Redis database. Implementing queues with Redis, that's a separate use case. And there is a package for Node.js, which is bullmq, which you can use to implement queuing sort of workload. But Redis is not optimized for queues. We should not use that as a queue. But SQS is a managed service which is handling these queuing workloads. And both have a very different latencies, both have very different sort of workflows and very different use cases, right? At scale, whatever tricky things that you can do with databases, we should not try that in production. So let's say I can use my Postgres as a queue as well, but I don't want to do that in production because it's not optimized for that. At scale, it will somehow fail, it will someday fail, right? So we use all of this, whatever I have told you, we use all these use cases in some way of the other. I will not be able to tell exact use cases, but I've given you similar use cases and Zoopy uses in a similar way. We have pub subredis, storage, rate limiters, everything. We do a lot of things with Redis. Yes, we use all types of technologies like RabbitMQ. We used to have, but that also started failing at a scale. So we moved to SQS, right? So it all depends at what scale you are operating. That defines what technology that you will choose, right? At one scale, you might not be able to handle all the use cases from a single RabbitMQ server, right? You might need something more managed, more scalable, which I should not worry about it, that my RabbitMQ server will crash, right? And I have seen crashes, right? And that caused a very big downtime as well, right? RabbitMQ crash. Right? So So usually companies stick with one provider because you used a lot of managed services, and in a like very long duration of time, you get used to using the managed services. Lot of your code is inside managed services, lot of pipelines, workflows that already gets built inside the cloud. So you definitely don't want to switch to multiple clouds. Or if you plan to manage your code in such a way that you can shift to any cloud anytime, then it needs to be an organization wide effort that you don't want to use any managed service. You want to have all your code, all your scripts very handy and ready that you can deploy it anytime on any cloud. No, Kubernetes is also very much included inside the cloud itself. So every cloud provider has a managed Kubernetes service. So Amazon has EKS, Azure also has AKS, right? So they provide managed service inside the database, inside their provider. So let's say if you are creating a pod, so a EC2 server will come up that will be called as a EC2 Kubernetes node, and on those nodes pods will get deployed, and it's all ingrained inside the EC2, basically what do you say, AWS. If you want to do Kubernetes deployment yourself, it's a very big effort because you need to manage EC2 instance itself, right? You need to manage all those scripts yourself that you want to create a new server. And definitely again, to create a new EC2 server will be different from creating a new Azure server, right? Your Terraform scripts might be little bit different, right? So it might seem like cloud migration is easy, but it's not. It's very, very difficult. And Kubernetes also, it's very, very ingrained inside the cloud itself. It's not something that you can go and deploy a very big Kubernetes cluster for production level safety and all, right? Because there are a lot of things, not just pods, auto scaling, there are certificate management as well, right? And it's very easy to do that inside cloud. You can just use UI to do that, but doing that manually uh, is very, very difficult. But yeah, the basic concepts of Kubernetes will still remain the same. And on outside, you will not be able to see any cloud specific thing when you are managing from normal Kubernetes tools. But yes, internally, cloud will use their own services. Hmm. Do you think only 50,000 requests per second we can handle? No. So we are handling much more than that. And that's not just uh, API request, right? There are gameplay connections, there are socket connections, there are internal use cases as well. 50,000 is a very less number. No, so Redis, we have a lot of servers, not just a single server. We have Redis server for all microservices. Every server might be overloaded with a lot of requests. So it all depends what kind of server it is, what server can handle how many amount of request. It all depends on workload itself. So let's say I have a server which is only handling increment use cases. So I can go up to 80,000 requests per second easily. But I have a socket server, let's say. I want to publish to 10 million users a notification. Then that particular single Redis server will not be able to handle. I will need a very big Redis server where I have a lot of subscribers and I will push it. And that will be CPU intensive server. So we will have separate servers for this. So this is how I think you asked about why do we self-host. So we tried managed services. What they do is they give you a very basic sort of server configuration. Let's say they give you 16 GB, 4 core CPU. But my use case is I want 8 core CPU, 16 GB memory. I want cores higher. There is no provider that is doing that, right? Because I want my application to be very use case specific, my servers to be tuned to a particular workload. I don't want all the workload on a single server, because if you have storage system as well on that particular Redis and you have PubSub use case also on the same Redis, you will not get that kind of performance out of that. But if you just separate out the infrastructure, I have PubSub server separate, storage server separate, I will get a very good throughput from both the servers, right? So we maintain different Redis servers for different use cases, different microservices, different games. Everything is different, right? And that's the way how you scale your databases. Because databases, you should definitely not go for a very, very big database and just try to scale it for a very long time. Because there are limitations as well. So let's say you go to a 16 TB hard disk, right? So there is limit of 16 TB on the cloud. What can you do now? No. So on a particular server, you can maximum have 16 TB of SSD. But if you think like, I want all my tables and everything on a single database, that is not a very good idea, because at 16 TB, your performance will start get hampering, right? So you want to split your databases into separate use cases, separate microservices, right? Denormalize your database, split it into multiple servers, right? And separate out. So in MongoDB, you can like easily separate one database from the other, right? One collection, you can just move it to another server. You can use from there. right? In SQL, it's a little bit difficult because there is foreign key constraints and all. But yeah, you can keep databases separate and don't do that foreign key relations and all. And you can scale that to separate server also, right? So that's where MongoDB and all those things come in, where you can basically uh, move to a separate instance directly and scale it horizontally, right? So it can handle a lot of load right now. So we can easily handle, I think, a lot. Whatever number I will tell you, we will be able to handle 10 times more than that, right? Not downloads. So let's say you have 2 lakh players playing once at a particular second. Our systems, every organization, whatever organization you pick, they will always have a buffer of, let's say, twice the scale, right? If you have 2 lakh players playing every second, our systems are able to support, let's say, 4 lakh players per second. But you definitely don't want your system to be able to scale 100 times the scale, because there is no reason to do that, because you won't achieve that kind of scale. And every scale that comes, it comes from humans, right? Where will you bring 10 lakh humans for every use case, right? So how much you want to scale your system, it all depends on your traffic, right? Hmm. Hmm. Yes. हाँ, वो अनलॉक हो जाएगा. First come, first serve. So basically, I'll explain visually. So let's say you are able to see cursor, right? So let's say this is my API function, okay? And a request comes in that I want to book this seat number. And what will happen is I have started my transaction. I've clicked on pay, right? And when I have just entered the OTP, this log starts, okay? And in 2 seconds, at least some confirmation will come that your payment has gone through or it's in processing or something, right? So in 2 seconds, this will get unlocked, right? Another user, if this transaction got successful, this will get unlocked and it will saved into the persistent database directly. Okay. Even if on the next call, other user was already in progress, that will come, that will see that it is able to acquire lock, but then it will go to check the seat availability. Then it will come from database itself that the seat is not available, right? And this is what happens in real systems. Like we can directly see these race conditions happening. And that is when we thought that we should have some sort of locking. And then we found out that we already using Redis and it has a Redis lock facility available. We can use it, right? And there are different kind of locking use cases. Redis is very simple, like single lock, but there are sequential locks where you want much more functionality, like persistence of the locks as well. Let's say in banking systems where you want like sequential lock on one step, second step, third step, then you might want to use some other tools like Zookeeper for more like persistent coordination and all, right? You might not want Redis in all the use cases. So it depends what kind of lock you are using, right? आप कितने भी देर के लिए लॉक कर सकते हो इसे, but usually you don't want to lock, right? So let's say for this particular seat number you should lock. So this lock that you are adding should be very specific, this key, right? If you logged for lock seat bus ID, the whole bus will get locked. So don't do that. Okay. Any more? Mhm. So Zookeeper is a separate thing. Zookeeper is another database which is mostly used for coordination. and config management. So we use Zookeeper for config management. A lot of organization, I think Flipkart also uses for Zookeeper for config management. But Zookeeper is a very separate use case, which is not related to Redis at all. Right. So Zookeeper is used in very different sort of architecture, not in these very simple implementations. Zookeeper is not required. Hmm. So usually Redis is deployed in a way it is fail safe. Like we have deployments in Sentinel mode or cluster mode. Okay. Usually Redis doesn't go down unless something is wrong in the system. Okay. If there is very high throughput or something is crashed and people are retrying a lot, then operations might increase, but we have rate limiters everywhere. We have rate limiter on container level, we have rate limiter on Redis global level, right? So, and those infrastructure also you can separate. You can separate out infrastructure for locking directly, right? And keep that as a managed service, let's say, right? AWS has a managed service called Elasticache. You can separate out infrastructure for locking. You can separate out infrastructure for rate limiting. And there you have high availability of systems, right? That's how you can manage very easily. Although it might seem like I'm throwing away a lot of infrastructure, but it's not. It's very small amount of cost that you can have in your systems. When you have more than 2000 servers, one Redis server is not much cost, right? Any more questions? Any more general questions you can ask?
All right, we'll call it here. If you have more questions, Sumit is around for a while. मैं भी यहीं पे हूँ. And जो लोग Oculus के साथ experiment करना चाहते थे, वो room में आ जाना. I have it. I can give it to you guys. That is it. Over for today, guys. Thank you.